Hi guys, my name is Soham Doshi and I am in third year of Electronics and Telecommunication Engineering at SPIT College Mumbai. So on this YouTube channel, we'll be learning class ninth Maths and Science and class 10th Maths and Science. So today we'll be learning the first chapter of class 10th Mathematics, that is real numbers. So, I just want you to get a clarity on what are numbers and what all types of numbers we have in general. Okay, so let's say I hope you all know that we have different types of numbers. By which I mean, firstly we have just a second. I'll just okay. First we have natural numbers. I'm sorry for my handwriting. I'll definitely try to improve it. Natural numbers are all those numbers that we can represent on number line, but these all numbers are positive in nature. So one, two, three, and so on up till infinity, all are natural numbers. Second, we have whole numbers. Whole numbers is basically basically you include zero in in the set of natural numbers. That is zero, one, two, three, and so on. So this is the whole number. These are whole numbers. Then we have integers as well. Integers are something that we can represent on number line. So it includes -1, -2, -3 up till infinity, 0, 1, 2, 3 until infinity. So these are all numbers. What do we mean by real numbers? What are real numbers? So basically we have seen that particular this set belongs to the natural number. This set belongs to the natural numbers. This set belongs to the whole numbers. Okay, these are integers. All the numbers rational plus okay, yeah. We also have something we also have something called as rational and irrational numbers. So what do you mean by rational number? Rational numbers are the numbers that can be represented in the form of p by q. So, for example, let's say we have 2 by 5, that is 2 upon 5. So, we can represent 2 upon 5, which is equal to 0.4. So, this is a number that we can represent in the terms of 2 in the terms of 2 p by q. So, these are all rational numbers. Then, what do we mean by irrational numbers? Irrational numbers are generally like root 3, root 2, then say pi, because pi is 22 by 7 and its value is 3.14 and it goes till infinity. So 3.14 and it goes till infinity. So these are all rational and irrational numbers. So what are real numbers? Real numbers consist of all the numbers, that is integers, positive integers, negative integers, rational, irrational, etc. Everything. So basically we can see that in earlier sections also you have discussed about real numbers and encountered irrational numbers. So real numbers are something that includes all the numbers that are possible and that can be shown on number line. You can also see the definition, real numbers. Here, real numbers are the set of numbers that represent a quantity along a continuous number line. So if we see the images, uh, huh, we can see that we have natural numbers, and we have whole numbers, and integers, and we have rational numbers. Then we have irrational numbers, and all and the sets of all of these numbers belong to real numbers. Real numbers is a big whole set. Assume a real number has as a father. Real number have real number have has two. children, one is rational, one is irrational, and then further it is divided into many more sections. I hope this is understood by you. This chapter is very small, and it doesn't have much any like concepts to learn, but yeah, very small chapter. So we'll just quickly go through it and end this video as soon as we can. We have next up we have the fundamental theorem of arithmetic. So the fundamental, I'll just read the statement for you. If the fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factors occur. So basically it states that, let's say I have a number, I'll say 9. So I can represent 9 in terms of its prime factors. Okay, what are prime factors? Prime factors are something that prime numbers are something. Let's say I have 3, I have 6, and I have 9. So 3 is only divisible by 1 and 3. 6 is divisible by 1, 2, 3, and 6 itself. 9 is divisible by 1, 3, and 9. Prime numbers are the numbers that are divisible only by 1 and the number itself. The numbers which are divisible by 1 and the number itself are known as prime numbers. So basically, in from these three numbers, number 3 is prime factor, is a prime number. So basically, then what are prime factors? So every number has got some factors. Where if we say 10, so we can write 10 as 2 into 5, right? So now 2 is also prime number, 5 is also a prime number. So basically, these are the prime factors of 10. So basically, we cannot further divide them, or these are not divisible by any other number. For instance, we had 10. We can write 10 as 1 into 10 also. But again, we can write to 10 as 1 into 2 into 5, right? So this is what we call as prime factors. So I hope you have understood this. So theorem 1.1 states that the fundamental theorem of arithmetic states that every composite number can be factorized as product of primes and their factorization is unique. As you saw the example of number 10, it can be factorized as the product of primes. These are prime numbers. Okay. These are the prime factors of the number 10. So this is what our theorem states that it states. Okay, I hope that this is clear. You can also see that. So we have for example, they have taken 32760, a very big number. But if you go on dividing it by 2, 3, 5, and 7, you will definitely get a remainder, and it is again a prime number. So we can see that they have factorize 32760 as 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13 as a product of primes. Basically, you can say that 3 times 2 means 2 to the power 3, then into 3 to the power 2, into 5, into 7, into 13 as product of power of primes. So this is what the fundamental theorem of arithmetic states. Okay. Next up, we have, okay, now you all need to learn the concept of HCF and LCM. HCF, LCM. Let's say I have two numbers, 6 comma 10. Here also we have 6 comma 10. So I'll just give you the definition for HCF. HCF is the highest common factor, is also known as highest common factor of two or more numbers. It is the largest number that divides all of the given numbers without leaving a remainder. So basically, we need to find a number that divides 6 and 10 exactly without giving any remainder, and the number should be very high. For example, if you take 1 also divides 6 and 1 also divides 10, but this is not the maximum possible number we have. We need to get more, we can get more, one more number as well. So this is not the highest one. Okay, so what are the how do we find HCF? Let's say we need to find HCF by the method of prime factorization. So what will we do? We write 6 and 10 as a product of their primes. Let's say 6 is written as 2 into 3. 10 is written as 2 into 5, right? So HCF is given by HCF is given by the product of the smallest power of each common prime factors in the number. So now the smallest common factor is 2, and the smallest the common factor is 2, because 3 इधर present है 6 में, but 10 में नहीं है, और 5 10 में present है 6 में नहीं है, तो common factor तो 2 है, and उसका least जो power है that is 1. So 2 to the power 1 मतलब 2. That is the HCF of number 6 comma 10. We can also find the this by okay, right. Excuse me. Huh. Then next up we have LCM. So you'll say what is the definition of LCM? LCM stands for least common multiple, which is the smallest positive number that is divisible by two or more integers. So basically, we need to find a number that is divisible by 6 and 10, and that is that the number should be least. Okay, so basically if we take 60, 60 is also a number that is divisible by the 6, because 6 times are 60 and 10 6 are 60, but that is not the least number we have. There may be more numbers less than 60 present, so that is why we need to find the least common multiple. How do we find it? Again, we will write the 6 and 10 as the product of their primes. Is 2 into 3 and 2 into 5. Okay. Now we have product LCM as product of the greatest power of each prime factor involved in the numbers. So basically, we need to take all the factors. Like if you have common factors, then we need to take the maximum power of the common factor and other prime factors as well. So here LCM is equal to 2 to the power 1, because that is the only common power we have. 3 into 5. Mm, My bad. So if we multiply it, we get 30 as the answer. As you can see, 30 is less than 60. So that is a 30 is LCM. One more method to find LCM is the division method. That is, we write 6, comma 6 and 10 like this. Then we will divide it using the least number possible. So we'll divide it by 2. 2 3s are 6, 2 5s are 10. Now 3 and 5 are prime numbers. They are divisible only by 1 or 3 or 5. So firstly we'll divide 3, 3 ones are 3, and we'll keep 5 as it is. Then we will use 5. This one will come as it is, and this 5 and the 5. So now we got the remainder. We have exactly divided the numbers. We for LCM we just need to take the products of these numbers. We need to take the product of these number, that is 2 into 3 into 5. Again, that is equal to 30. So this is how we find HCF and LCM. I hope this is understood by you. You can practice examples given in the NCERT book. Like we have here example, find the HCF of 96 and 404 by the prime factorization method. So what they have done, they have written 96 as the product of prime numbers, 2 into 5 into 3. And they have written 404 as the product of their prime numbers, 2 to the power 2 into 101. So HCF is again the least is the prime factor that is common, and power should be as less as possible. So 2 is common in both of these numbers, and the least power of 2 is 2 to the power 2. That is why HCF is 4. And for LCM, we also have this formula that can be used. You may refer the textbook to find out this formula. I hope this is clear, and we can move further. If you have any doubts, please put it in the comment section. I would definitely love to clarify them. And also, please provide some feedback, whatever you want me to improve. I'll definitely try to incorporate those things into my teaching. And yeah. So moving further, we have irrational numbers also. I just explained you what are irrational numbers. Again, irrational numbers are the numbers that cannot be written in the form of p by q, where p and q are integers and q is not equal to zero. Definitely, obviously, if q becomes zero, then this number becomes infinity, because anything, let's say anything upon zero is infinity. Okay, you will learn this in higher standards. So yeah, we have root 2, root 3, pi, minus 2, minus root 2 upon root 3, etc., etc. Theorem, now we need to learn theorem 1.2. That is, let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. So if we say, take an example, let's say a is 2, p is also 2. Okay, so p is a prime number. If p divides a square, so let's, what is a square? A square is 4. If p divides 4, yes, p divides 4, because a square by p is equal to 4, is equal to 2. Sorry, my bad. So yeah, this divides, then p divides a. Yes, again, if you write a upon p, then 2 upon 2, and we get the answer as 1. So this is what the theorem 1.2 states. You may refer the textbook for the for its proof, and I assume that your school teacher also has explained you the, this proof. Next up, we have theorem 1.3, that is root 2 is irrational. So to prove this, I'll suggest you that you read it from your textbook. You'll definitely get it. If not, then please let me know in the comment section. I'll definitely make another video to explain root 2 is irrational. So for to prove root 2 is irrational, we assume the contrary part, that is root 2 is rational. So basically, we'll try to prove that root 2 is irrational, but moving further, we'll get to know that root 2 is not rational. So that is why it obviously becomes irrational. So this is how we prove that root 2 is irrational. Again, next you have examples that prove root 3 as irrational, and you also have many other examples also. Okay, also you also need to keep in mind that the sum or difference of rational and irrational number is irrational only, and the product and quotient of a non-zero rational and irrational number is irrational only. That can be, again, you can take any example and then you may write it. Okay. So next up we are okay. So next up you have exercise, that is you need to just prove root 5 is irrational, prove that through 3 plus 2 root 5 is irrational. So I guess we are done with our first chapter of mathematics. This was a very easy peasy lemon squeezy chapter. Just refer the textbook once, read all the proofs, get to know how are all the theorems proved. Also, you may refer your school notes to get the proofs, and practice questions on LCM, HCF, and memorize how to find LCF, LCM, and HCF, and also what do they mean, etc. stuff. Also get hands on the theorems, their proofs and examples. Learn how to prove all of these things. For example, root 5 is irrational, etc., etc. Okay, I think this is from my side. We are done with our chapter one. Further, we'll also put up videos for science, and chapter two we'll continue with polynomials. That is our chapter two for class 10th maths. So yeah, see you in the next video, guys. Thank you so much for watching. Take care. Bye bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।